Good morning, good afternoon, good evening, good night, wherever you are watching this. Today we're going to be talking about acids and bases. So there are many definitions of acids and bases. The one that we're going to be focusing on is going to be Bronsted-Lowry. Have no clue what these guys, or even if they're guys, or I don't know what they identify as, but these are two individuals. They basically came up with the idea that acids are going to be any type of molecule that primarily donates H pluses. Bases are going to be the ones that are going to be primarily taking H pluses. And so let's draw a quick example of that. Hopefully you'll be able to recognize this. If I drew this hydrochloric acid and I put it in solution with NaOH. Now, at this point, you've probably taken a year plus of chemistry. And so you'll probably be able to recognize that, oh, yes, this over here is an acid. And I also said it in the name too. And this is the base. And so what's going to happen is that if you throw these into a solution, they're going to do something called, what's called a proton transfer. And it sounds exactly like that. They're going to transfer a proton. Now, what's going to where is going to be very dependent on what category they fall into. And so this HCl is going to be the one that's going to be donating the H. This NaOH over here is going to be the one that's going to be taking the H. And so it's very important that before we begin, we have to understand that if there's any type of like metal attached, like Na, sodium, anything that's on the far left side of the periodic table, and if it's hooked up to a non-metal, chances are what's going to happen is it's probably going to dissociate. OH. Yep. If this confuses you why I'm drawing all these weird little symbols here, these little dots right here, please go see my other video about formal charge. And what's going to happen is that these two are going to dissociate. This is going to become a spectator ion, which means that's not going to do anything. Spectator means just watch. It's going to stand back and watch. And this HCl over here, well, it's going to be the one that's going to be donating the proton. And so, when you conduct a proton transfer, you take your base, you find a lone pair, and that lone pair is going to go, it's going to grab that H. Now, this is a very, very key step right here. I'm actually going to outline this in red just of how important it is, right? But when it comes to anything in organic chemistry, when you're doing a reaction, yeah, whether it be some sort of proton transfer or just any other reaction, when you draw your arrows like this, you always go from electron rich to electron poor. I swear, this is so important. I cannot even like fathom to like I can't even comprehend how like I can't even put the words together. Look, I'm studying right now, but I can't even put the words together about how important this is. I've seen too many people start off their reactions with, okay, I start off from this H and this H is going to go here. No, 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 no. You start your reactions from lone pairs or from electron rich areas, right? Because this lone pair represents electrons. This is electron rich. This is relatively electron poor. And you start your reaction from there. All right. And so what's going to happen in response? Well, what's going to happen in response is that once this little OH over here, the lone pair goes and grabs an H, think of it as like a cowboy trying to wrestle like a bull that's gotten out of its ring. You know, like you take a little lasso, you grab it, or it's like a grappling hook. If you're a big fan of Batman, I think Batman has a grappling hook. No clue, not a DC guy. But after that, these electrons are going to pop into this bond right here. Yeah. And so what's going to end up happening is that I'll color code this for you as well, right? I'll color code this thing purple. But you are going to end up with a Cl that's kind of just chilling on its own. Yeah. And then you'll end up with a H here. I'm going to highlight this in another color for you to see. Yeah. Okay, so to essentially backtrack and kind of give you a overview from ahead, from 1,000 feet above. So what we did here, right, is that this OH, this base right here, basically broke apart. Na plus goes off on a vacation to Spain somewhere. So sit back and watch. And then your base is going to start off from electron-rich areas, right? This lone pair is going to go grab this H right here, and that H is going to be as you can see here, right? That OH kind of just lassos that other proton real quick. And then this pops off, the electrons that are in this bond right here pops off in response, and you end up with this uh, anion species, right? This negatively charged molecule, not molecule, sorry, negatively charged thing. I don't know what's the right word, on its own. That's basically the basics of this. And maybe hopefully it's come to the point where you guys are kind of just rolling your eyes at this point because it's like, well, I mean, we already knew this, right? I mean, how important can this be? Well, it's important because of this. And I'll prove to you why it's important that you master this proton transfer, this kind of archetype of reaction, of operation, mainly because oftentimes you'll find yourself in a situation, let's say for example through some sort of reaction, right, where let's say for example you end up with this molecule right here. Yeah, let's say you do whatever A plus B plus C reaction, you end up with this at the end. Yeah, this is your product. You can't leave your product like this, right? If you just have like a positively charged like product, ideally you're not supposed to leave it like that. Some other chemistry professors might be different, but I know Dr. Ko probably doesn't like you to be like this. And so what's going to happen is that you're going to have to do a quick proton transfer. This has to be reflex, like breathing or flinching when somebody throws like an object at you when you're not expecting it, right? If you see something that's positively charged like this, you have to be able to clean it up with a proton transfer. And the interesting thing about organic chemistry at this level, right, is that Dr. Ko doesn't really mind if you whatever base you use, as long as it's present in the solution. Now, oftentimes I've seen people use H2O because as you guys know, hopefully, H2O is it's AMPA product, which means that it's a good acid and a good base simultaneously. It can be either or, depending on the context. But you could use H2O, and you could do this, grab this, and then you end up with a quick proton transfer, and then your product will end up neutrally charged. And then you end up with a positive, as you end up with a positively charged hydronium species over here. It's pretty cool. It's pretty cool, pretty cool. And yeah, that's basically what proton transfers are used for. You need to use them really quickly to clean them up. But it's one of those critical things where if you don't master this now, then it could be a headache for you later. Oftentimes, also, I've also seen different scenarios where Dr. Ko will say this, for example, that's probably a bad color. I hope none of you are colorblind. I'm so sorry in advance. Where you'll have something like this, right? Whatever product. And then instead of using water, you can just basically just write base. Pops off into here. You end up with this. Oop, wrong color. Yep. So just in summary, right? Proton transfers are basically used in this class for the most part. I would say like 80% of the time, 90, probably 90. Yeah, 90 plus percent of the time as part of just a cleanup step. Yeah, you don't want your product to be positively charged. And so you just end up using whatever base that you have on hand, whether it be water or just like using this little generic base setup right here, where you can just grab an H and just clean that up really quickly. Seems simple, but it's very important. And so hopefully this provided some context. If you're struggling, if you're curious about proton transfers, right? If you don't know how to do them, and hopefully this helped. And remember, always go down fighting. See you later.